G'day everyone. I had an interesting problem last night with a fuzz face that I was building, and I've since corrected the problem, but I thought it'd actually be an interesting video to show you the steps that I took to actually narrow down the problem. And I've actually reversed the problem back onto the board so that the board's faulty again, and I'm just going to show you the steps that I went through to actually resolve the problem. I just wanted to mention something related to fault diagnosing just before we go on to the fuzz face. You've probably invested a lot of time, and you maybe even invested a lot of money, and your expectations are high, and you know you've built the effect, you plug it in and it doesn't work. I don't think there has probably been any do-it-yourself guitar pedal builder that hasn't at some stage sort of beaten themselves up, or felt like a bit of a failure. Like, I mean, even if you're up to number 20 pedal, you may build your 20th pedal and all of a sudden there's a problem that you just cannot find the answer to, and it really does drive you crazy, and you feel like, like, I've come this far and I still can't build this pedal. It drives you crazy. I've seen some people on the forums really getting hard on themselves, and I suppose also the other thing too is that the scope for error starts to really broaden. I mean, when you plug the guitar pedal in, you get nothing out the other end. All of a sudden your mind starts to race on all these areas where the problem could lie. I could have stuffed up the wiring. The transistors I've used are wrong. I've put them in the wrong way. Something's not working on the board. The polarity, and you sort of start to get carried away with, the walls feel like they're closing in on you. It really, it sounds dramatic, but it really does happen. It's important to remind yourself that the large majority of problems that you have, 99% of the problems that I have, are wrong component value, solder bridges, or something else that I've done that I've stuffed up on the actual effect. It's much easier to start with a few of the common things that happen when, like a few of the common faults that happen, and look at those first, or something that if you've got an inkling that there's something that you've done that you're a bit suspect about, start with those easy things first before you start getting into the complicated stuff. It's kind of like fault diagnosing with computers, the same sort of thing. You start with the most logical answer, or the most common fault, and then you move on to the more complicated stuff, and it just helps relieve some of that stress that you feel when this stuff happens. So the problem with the fuzz face, this is pretty much where it was sitting last night. I had the effect plugged in and I was getting a clean signal, but I was not getting an effect. This is something that kind of happens quite a lot, but this problem that I'm having with the fuzz face is a little bit unique in this respect. So turn the effect on, nothing. Turn the volume up full, nothing. Nothing coming out at all. So there's no signal, there's no signal leaving the circuit. So the first thing I usually do when I encounter a problem like this is to actually scratch around the tracks and make sure there's no solder bridges. I've mentioned this in another video, but I'll just quickly explain how to do that. If you hold the PCB up to a bright light like this, you can see the tracks nice and clearly, and just go around and scratch out any flux that you might have, and just check with the schematic on your screen and make sure that you haven't actually bridged. See, because if you bridge two of these pads together, you may actually think that's the way it's meant to be, but there's actually no track underneath those two pads. They're not actually meant to be connected together. So check with the schematic on the screen, make sure that's okay, scratch around. So that's what I did last night. I went around, I scratched, and also, sorry, one other thing, scratch everywhere on all the tracks, not just around the pads, around all the tracks, because sometimes you can get some of the most finest microscopic bridges that you're never going to see, and they will come off just with a light scratching like that. So that's usually the first step that I do. Unfortunately, it didn't fix the problem. I plug it in and I still had the same issue. Solder bridges account for the large majority of problems that you're probably ever going to have. I would say, particularly once you get the whole values, you know, once you've worked out how the values work and how the components go in on the board, the solder bridges will be the thing that will vex you for all eternity. I still have issues with solder bridges. I don't have as many issues as I used to. It also depends on how the person's made the layout. If they haven't made much clearance between the pads, you know, it's harder to solder. You've got to be really skilled and not sort of link them together. You know, I mean, even then, you still get the issues. So, solder bridges, number one. That's usually the first thing that I check. The second thing I'm going to check is that this board is my own layout, and I've put the charge pump on the board. That's what that chip is down there. And as charge pumps work, you've got the plus 9 volts that come in on one side and the negative 9 volts leave on the other side. So I'm going to check that voltage and make sure that I'm actually getting negative 9 volts out the other side, because if I'm not getting negative 9 volts out the other side of the charge pump, then nothing's going to work properly. If I am getting negative 9 volts out the other side, then that will pretty much confirm that the whole power section of the board is working properly, so I can start to look at the actual fuzz face effect after that. So you put your negative probe on ground, obviously, and your multimeter on DC, and then I know which pin on the charge pump is connected, is the output, the negative 9 volts, and as you can see on the screen, it comes up at negative 8.7 volts. So that makes me believe that there is nothing wrong with the charge pump section, the power section. It's supplying the correct power to the rest of the circuit, which is the fuzz face. So I'm just going to probe around some of the two transistors and see what voltages I get with those. This is the exact process I went through last night to get to the root, the cause of the fault. So now I'm just going to check the transistors and see if they're working properly, and just check those voltages. And let's just check Q1 first. And Q1 has a emitter that's connected to ground. Bring up the fuzz face schematic if you want to follow what I'm doing here. And it's as you can see, it's 0 volts, so that's correct. And then the base is negative 1 volt, and the collector is negative 0.45 volts. Now that seems like, just from experience, that seems like it's probably about right. Usually the collector should be higher than the base. I'm not quite sure if there's a situation where the base would be higher than the collector. Some of the experts might be able to straighten that out, whether that's right or not, but from my experience, usually the collector should be higher than the base, and in this case it is. So I'm going to assume that Q1 is okay. So let's check Q2 now. This is the collector, and it's negative 8.65 volts, which is almost the supply voltage. So if we look on the schematic, there's probably no resistor, or a very low resistor that's connected to the collector, because it's pretty much the whole supply voltage. Which is good. That's what probably I'm assuming what it should be. I haven't got the schematic in front of me, but that sounds right to me. The base is negative 4 volts. So there's that negative 4 volts again. So that was connected to the collector, which was negative 4 volts. And I'm pretty sure on the schematic that's how it's supposed to be. The base of Q2 is connected to the collector of Q1. So that looks good. And then you've just got on the emitter 0.4 volts. So to me that looks like it's functioning properly. Those voltages look correct. So what's going on? I mean, the voltages are all okay, but I'm getting nothing out from the output. So I've said before, you don't need to be an electronics engineer to build guitar pedals, and I mean, I've only got very basic electronics knowledge, but it does help to understand some of this stuff. Even if it is just the basics, for when you encounter a situation like this, because understanding how the volume control on an effect works is actually what sort of pretty much solved it for me straight away, and it really cut down the time of fault diagnosing this thing. If you watched my video recently on how the explaining how the volume control on a guitar pedal works, you'd know that as the resistance gets lower, the output voltage will get lower as well, which means you'll get less signal. So if you've got 500 ohms resistance on the output volume, you're going to get a very low signal. If you've got 500k, you're going to get a very high signal. You're going to get more signal out as the resistance goes up. I didn't physically check what potentiometers that I soldered onto the effect, and if we have a look at the potentiometers, as I said before, I actually reversed this problem, but this was the problem that I had, and the sequence that I went to fix it. You'll notice that the volume control is 1k and the fuzz pot is 500k. I've only got 1k on the volume control, which means that it's basically 1/500th of the volume out of the effect. You're not going to be able to hear that. You probably, unless I actually cranked up my amp, which I'm not going to do because I'm in test mode here. I'm not just going to crank up the amp and see what's going to come out. So I probably would have had trouble actually finding the fault here if I actually hadn't known how the volume control on a guitar pedal works. It made it quicker for me to narrow down the problem. I would have found it eventually. It just made it quicker. One thing I forgot to mention was the transistors. I actually checked the pin out of the transistors to make sure that was correct, because I found that if you put them in the wrong way, sometimes you get no output. So that's, if you're getting no output, yeah, check the transistor orientation. Sometimes that can cause that. So I've swapped the pots around now, and clean signal and fuzz. So it's all working as it should now. I know this one was, you know, like something that you'd sort of, I would have worked out eventually that it was the potentiometers that was the problem. But this is the sort of common issue that you can have when you build your effect and you're not getting anything out of it, or you're getting the wrong result. It's often just something simple like that. You know, it can get complicated sometimes, but just take the mentality of, you know, I'm just gonna cross things off the list, starting from the most common or the most obvious, and then working to the more complicated stuff. And it's just a little bit less stressful when you do it that way. So I hope you gained something out of this video. I'll do more fault diagnosing videos because it's obviously a common part of building guitar pedals, and it's probably, in my opinion, probably one of the more useful things to learn. You know, constructing a pedal's not always that complicated, but actually getting it going can be the hard part. Thanks for watching, and don't forget to subscribe if you want to see more videos on guitar pedals and guitar pedal electronics.